Hi, I'm Upashana and my data mining seminar project is Normalization of Extracted Named Entities in Text Mining. The objective of the project is to develop a domain independent method for the normalization of named entities which are extracted by text mining. This is basically synonymous to entity resolution, where we perform two tasks: entity matching and entity name clustering. Here, normalizing a dataset actually means entity clustering, since clustering is based on distance between the data and each cluster represents an entity. The domain independent here means that the model will work without any knowledge of the source or language of the entities. So, for example, if text mining extracts four named entities such as person, company, organization, and location, the goal is to create four new entities: normalized person, normalized company, normalized organization, and normalized location. The whole project has actually two aspects. This like doing entity matching first with edit based technique, which is here in this case we will be implementing soft TF-IDF, which we will discuss in details later, and deep learning technique. The soft TF-IDF technique has been the related work of that part has been discussed previously, so in this report or poster we will just focus on the deep learning aspect of the project. Coming to related work, there has been very few works, few relevant works which are mostly recent in this area. So the first comparative study of convolution neural networks, recurrent neural networks, and gated recurrent units have been done by Wen Peng in 2017. They took four different NLP tasks like sentiment classification, textual entailment, relation classification, and applied this technique on this NLP task and calculated the performance. So the NLP tasks they considered, let me just go through them in short. Sentiment classification, the goal is to predict the sentiment of movie reviews, whether it's positive or negative. Relation classification, it just consists of sentences which have been manually labeled with 19 relations. Textual entailment consists of positive entailment, negative entailment, and neutral with the premise hypothesis pairs. Here, accuracy is measured with prediction. In the results part, the results showed that gated recurrent unit performs the best on sentiment classification and comparably with convolution neural network in relation classification. For textual entailment, GRU again outperformed the LSTMs. The unexpected observation here is that recurrent neural networks outperforming convolution neural networks in sentiment classification, despite the fact that CNNs are good in extracting local and position invariant features, and sentiment classification mostly depends on some local features rather than the semantics of the whole input, which led to the quantitative analysis of this bizarre finding. In a whole, the conclusion of the project is that the performance of CNN or RNN architecture improves depending on how important it is to semantically understand the whole sequence of text, which actually is the reason behind this behind the bizarre finding we just said. And number two is the performance is largely dependent on the model hyperparameters like learning rate, batch size, hidden layer size, etc. The second relevant study in this field is in the paper by Mudgal et al. In 2018, who studied the benefits and limitations of DL when applied to EM problems. The paper mainly focused on applying four representative DL solutions like smoothed inverse frequency, SIF, RNN, attention, and hybrid versus Magellan. Magellan is a state of the art statistical learning based EM engine. They applied all of these solutions to to the dataset, which has been split into a 3:1:1 for training, validation, and testing. For Magellan, classifiers like decision tree, naive Bayes, and logistic regression have been trained. The major goals and takeaways from this paper is that the goal of this paper is actually to understand where DL outperforms current EM solutions and the impact of various factors like model complexity on the performance. Since my project is concerned with textual data only, we will focus on the results obtained on textual data. Coming to results and conclusion, the conclusion of the project was that deep learning outperforms Magellan on textual EM tasks. The difference is not considerable if the data contains informative attributes like titles, which might contain very specific information, but otherwise it becomes significant. The result also proved that the hybrid model they implemented as the best model among the deep learning solutions only when the training data available is small. Then only the complexity of the model is actually boosting the performance. Otherwise, if a lot of training data is available, even simple DL models perform quite good. So now, based on the related work and the objective of our project, we can formulate the research questions, which are the following, like what is the performance of our deep learning model for both training datasets and real world polluted dataset. Number 2 is what is the performance improvement of the deep learning model over the baseline model of soft TF-IDF, and also what are the pre and post processing methods which can be used or modified to increase the performance of both the soft TF-IDF and the deep learning model. This is the overall approach of the project. Data collection, this is very important here because since the focus is on domain independent dataset, data preprocessing, which is also again an important part, then implementing soft TF-IDF as a baseline model, then and next implementing deep learning model like LSTM, and at last performance analysis. Let me give you a short overview on this method called soft TF-IDF. Soft TF-IDF is found to be the best performing edit-based technique by the paper, by the project, by Cohen et al. It is actually a combination of token-based weighing scheme, which is TF-IDF, along with edit-based distance measurement techniques like Jaro-Winkler or Levenstein distance, which can be chosen according to the nature of the project. Now, the best part about it is it combines the good things of both the mechanisms. Like it doesn't, like for example, it doesn't take into account the equality of word if the to put them in the same entity. So which is why it performs very good on the real polluted data. This will be implemented as a baseline model here, and then the performance will be, then we expect that the deep learning model will perform better than this. So naturally, from the deep learning aspect of the project, this question comes that why LSTM? We know that LSTMs, the full formula LSTMs are long short-term memories, and they are best suited for tasks with sequential inputs, where the input texts are very long and the model needs to remember the very earlier happening text as well as the recent texts. It's the prediction it's very useful in cases where the prediction depends on the semantics of the whole text. Like what I said, the whole text is important rather than some localized features or specific features. So we can take a very similar approach here to train the LSTM with real world text in combination with possible textual variations. The entire process, this implementation of the LSTM model, can be categorized into three steps: input sequence encoding, vector representation of the input, and the comparison method. So, the first one, in encoding, the input sequence encoding or embedding can be of two types: word level embedding or character level embedding. So, we know that character level embeddings result in the formation of, suppose, top 100 characters as we choose, top 100 characters dictionary. It is capable of turning any word in a d-dimensional vector representation, unlike word-level embedding, where the end result is a lookup table. This is a reason why character-level embedding generally performs better in case of out-of-dictionary words, which in this project could be a significant factor. So, it would be better to use character-level encoding in the first step. The next step is vector representation. Rather than training the embeddings from the scratch, which takes a lot of time, it will be easier to use pre-trained character level embeddings like fast text. Since it is trained over a vast vocabulary from Wikipedia, Google, using it will be an advantage for domain independent cases. Also, the end-to-end training time will be shorter, as I said earlier. And the third step is the comparison. There's a step where we compare the two summarized input vectors. So this actually means computing distance between the summarized vectors, which can be done with either fixed distant functions or learnable functions. The fixed distant functions can be cosine distance or Euclidean distance as we choose. For learnable distance functions, the classification module can be used to learn a distance function and apply. Of course, after all of this, the most important step is the evaluation strategy. Like as far as implementing deep learning modules go, the dataset will be divided into three parts: training, validation, and test set. Training set and validation set accuracy are important here to determine the fitting of the model, that is, whether the model is underfit or overfit with the data. Afterwards, we can use the testing set accuracy as our prediction accuracy and understand the efficiency of the model. Coming to the challenges and opportunities of the project, some of the challenges which I can identify are that since the project is focused on textual data, large amount of training data are required to achieve a good performance, which will be hard because acquiring all the training data and manually annotating them is also the pre-processing part is kind of tedious. Also, scalability of LSTM model is one big problem, as we know, but the opportunities of this project is like quite bright because since, as I said in the challenges, that annotating data manually is a very tedious work. To eliminate this need of manual data annotation, nowadays this weak supervision thing is very new, and devising a new weak supervision method to do this will be an interesting aspect of the project. And the second thing is if the LSTM model works successfully in real world polluted textual data, introduction of language insensitivity can be used afterwards. So this is all. Thank you. Hope I explained you well.